Hello everyone, and today we'll be seeing one of the problems from LeetCode. It says check if strings can be made with equal operations. And the problem is very simple, that we are given two strings s1 and s2, both containing n letters, so the length is same, and both of them are lowercase English letters. Now we have to do, we can apply one operation multiple times, and that operation is to choose I and j such that the difference of I and j is even, and return true if we can make s1 and s2 equal, or else false. So let's take an example. We have a, b, c, d and this string. So a can be replaced with c, with an s2. If c and b can be interchanged, well, I'm not sure what it is, but again I can replace this and this so that c is correctly in position, and I can apply multiple operations. Okay, so you can see what operations I can apply over here, and s1 can become s2, so not a big deal. But in this case, even though they are anagrams of each other, still we cannot apply any set of operations which will give us a true, because these are not having even differences. So how can we solve this? How can we navigate through this? You see, even differences is nothing but a way which they are mentioning us that hey, we can only swap evens index with even index, and odd index with odd, and odd with odd. Okay, and yeah, this is the crux of the problem. Now you have multiple ways. One brute force way, or one very inefficient way, approach one, is you can just take out even index, so even string, and you will have odd string. You have checked whether even string of s1 and s2 both are equal or not, and same goes with odd string, and then you check s1 and s2, and that's good. You can do that, but again it will consume your extra space of creating entire new string, and that's not very acceptable. That's not very recognizable. It will get you problem solved. What I'm saying is, if you're having a string like a, b, c and d, this is approach 2. Again, there are multiple approach. I'm not going detailed into everyone. I'll just finalize upon approach 2 and I'll just code it down. So I have this 0, 1, 2 and 3, and yeah, you can have multiple, don't worry. But my main goal is to understand that hey, whether index 0 and then let's say 2, then let's say 3 are anagrams or not of each other, and that's it. If those are anagrams, no matter what position they are, I can swap them anyhow and I can bring them into positions, and that's what I wanted to check. I'll have a function check, which will of course return a boolean, and that will have a string a, string b and a start. The start, my friend, is nothing but a for where I wanted to start. So int I is equal to start I is less than a dot length, oopsies, I plus plus, and here it's not plus plus, it's plus equal to 2. Why? Because this, I wanted to go from 0 to, and it's not 3, it's 4, 0 to 4 and so on. And now we have that, so let's have a table where we choose this a dot character at I minus a, and we can add this one here, and for b we can subtract this one. So now we have table populated. Let's check for int I in table. If I is not equal to 0, return false, or else return true. And again, I know that I have not created a table. Table is equal to new int of 26, because we know that it's 26 characters and it's all lowercase English letter. time complexity of this is O of n. Space complexity of this is O of 1, because we are not dependent on input spaces. We have a constant space of 26, and that's it. I can just go ahead and return, directly return, once I checked A and B for every even index, and I can do the same for every odd index, and provided this and this both should be true. It's an AND condition. Let's compile this. Oops, it says compiler error table. It's table, man. Cool, let's compile this now. And it has accepted for sample test cases, submitting this one. And yes, it got submitted, accepted for rest of all the test cases, and 100% solution beats. So this was about it. It was a pretty good problem, and yeah, if you wanted to see more such like data structure, string, hashing related content, click the video on your right, and I'll see you in the next one.